Everything you have ever seen, every star you've squinted up at, every stone you've kicked down a road, every breath you've drawn, and every stray thought that's ever crossed your mind, all of it, the entire visible universe, is built from a list of ingredients so short you could write the whole thing on the back of your hand. A few particles, a few forces, and one last field we only got to know last week. That is the recipe for everything there is. And here's the part that ought to stop you cold. This ridiculous little shopping list has been tested to a sharpness like measuring the width of a whole continent and coming out wrong by less than the thickness of one human hair. And in all the history of the thing, it has never once been caught out. So tell me how that can possibly be. How can everything be so few things? And how, in the name of anything, can we be that sure?
Both of those questions have answers, and I've been holding them back all season, on purpose, for exactly tonight. Because tonight we finally do the thing we've been circling since the first week. We stop meeting the pieces one at a time, a quark here, a ghost of a neutrino there, and we lay every last one of them out on the table at once, side by side, and step back and look. And I think the strangest thing of all is what happens when you do that. The parts were odd enough on their own. Seen all together, in one glance, they're stranger still.
All season, one piece a week. Quarks, the electron, its ghostly little partner, the light carrier, the glue, the weak pair. And last week, the field that hands out weight. And now you're finally going to tip the whole box out in front of me, all of it at once.
The whole box tipped out on the table. And I'll wager the first thing you feel when you see it lying there isn't awe at all. I think it's going to be suspicion.
Suspicion? Why on earth would I be suspicious of it?
Because it's too little. Think of the sheer variety of the world. Stone and water and starlight, and skin and iron and air, a million different substances, no two quite alike. You walk in, braced for a warehouse to match it, aisles and aisles of fundamental stuff, a separate bin for every kind of thing the world could possibly be. Thousands upon thousands of them, surely, to make all that. And instead I'm going to hand you something that fits, with room to spare, on the back of one hand. And your gut is going to dig its heels in and say, that can't be all of it, surely. That can't be the bottom. Where is the rest of it hiding?
And there isn't any rest.
There isn't any rest. That is the thing I have to make you believe tonight. And it's harder than it has any right to be, because it runs against every instinct you own. Big things are made of many small things. That's the rule you've lived by your whole life. So let me start with the part of the list you are actually made of, the matter itself. And even there, before we have gone anywhere near the forces, nature has laid out a surprise that nobody ordered, and that nobody, to this day, can explain.
And that's really why you saved it, isn't it? The whole box, all at once, because any single piece, met on its own, just looks like a random oddity.
Any single piece, on its own, looks arbitrary. Why this? Why a quark? Why a thing that spins just so and carries just that much charge? Meet them one a week, as we have, and each one is a curiosity you file away. It is only when you tip them all out together, in one heap, that the pattern jumps up off the table and takes you by the collar. The rows, the three copies, the way the forces slot into the gaps as though they'd been cut to fit. The meaning was never sitting in the pieces. It was always in the shape they make together. And that shape is the thing I simply couldn't show you until tonight.
All right, the matter then. When you strip me right down to the very bottom, what am I?
A tiny handful of things is what you are. The protons and neutrons in every atom of you are built out of quarks, and only two kinds, the ones we've been calling the up and the down. Then wrap those atoms round with electrons, and drifting through all of it, barely brushing against a single thing, the electron's shy little partner, the neutrino you met a few weeks back. That is the entire set, 2 quarks and 2 of what we call leptons, the electron and its ghost.
2 quarks, 2 leptons. 4 things.
4 things, and out of only those 4, you can build every atom, every rock, every star in the sky, and the entire living body of the person listening to this right now. 4 ingredients, and the ordinary world, in all its riot and variety, tumbles straight out of them.
Hang on, that actually is the whole of ordinary matter. Everything I have ever picked up or stood on or been, it's those 4, just heaped together in different amounts.
Those 4 in different heaps and nothing else. From your fingernail to the furthest galaxy there is, every stable, sit still and be a thing scrap of matter in the cosmos. 4. And if the story stopped right there, it would already be one of the tidiest facts in all of science. But it does not stop there. Because when we went and looked closely, really closely, we found something genuinely peculiar. Nature didn't make that neat little set of 4 just the once.
What do you mean, not just once?
I mean, she made it 3 times over. The exact same pattern. 2 quarks, 2 leptons, in the same arrangement, doing the same jobs, copied out again from top to bottom. And then a 3rd time. 3 generations we call them. 3 copies of one single template, stacked one above the other. And identical in every way but one.
Identical, but for one thing. What's the one thing that differs between the copies?
Weight. Each copy is heavier than the one below it, and that is the only difference there is. The 2nd generation is that same cast of 4, played by heavier actors. A heavier cousin of the electron, heavier quarks, a heavier partner ghost, the lot of them. And the 3rd generation, heavier again. Same script, same parts, same lines, just turned up in mass twice over.
And that first one, the heavier cousin of the electron, that must have been a genuine shock when it showed up. A copy of a thing you already had, for no reason.
An absolute bolt from the blue. Here was a particle that behaved for all the world like an electron. Same charge, same character, same everything, except several hundred times heavier, and nobody had asked for it, and nothing in the picture the least bit needed it. It fit nowhere. It did no job. It just arrived uninvited and then fell to bits. And the honest reaction, more or less, was, who on earth ordered that? For a long while, it looked like a single pointless oddity, a particle with no reason to be. It took years to realize it wasn't an oddity at all. It was the first corner of a second copy, the first hint that the entire pattern repeats.
And the little ghost, the neutrino, is there one of those per generation as well?
1 apiece. 3 ghosts, one riding along with each copy, each one fainter and stranger than the last. So when I tell you the pattern repeats, I mean it repeats down to the smallest, shyest member of the family. Nothing left out, nothing added. 3 complete copies of the one design, right down to the ghost in the corner.
And these heavier copies, where does anyone ever actually see them? Because I have certainly met a heavier electron walking about the place.
You haven't, and there's a reason for that we're just about to reach. But they are real, and we do meet them. They rain down on you out of the sky, made high overhead when something out of deep space slams into the top of the air. And we can conjure them ourselves in machines that pour enough energy into one tiny spot to build them fresh from nothing. So they are no fairy tale. We have made them, measured them, weighed them, right up to the great heavy quark crowning the 3rd generation, a single elementary speck that weighs more than a whole atom of many an ordinary element and still has nothing at all inside it.
More than a whole atom? And it's still one of the smallest, most fundamental things there is.
Heavier than a whole atom of many an element, and still with no parts inside it whatsoever. That is how far the ladder climbs. But, and here is the surprise I promised you, you cannot build a single lasting thing out of any of them. Not the heavy quarks, not the heavy cousins, none of it.
Why not, if they're every bit as real?
Because of what the heavy copies do the very instant they exist. They flicker into being when there's spare energy going, and then they last the tiniest sliver of a moment, gone quicker than any word you have for quick, and they fall to pieces. They decay. They tumble straight back down into the lighter, first-generation things they are copies of. They appear, they crumble, they're gone. And you simply cannot make a brick out of something that won't sit still long enough to be stacked.
So nature made 2 whole spare sets of the building blocks and then never uses either of them for anything that stays put.
Never uses them for a single thing that lasts. Only that first generation, the up quark, the down quark, the electron, its neutrino, builds the ordinary standing world. You, the ground beneath your feet, the sun overhead, the furthest galaxy there is. First generation, almost to the very last speck of it. The other 2 copies build precisely nothing. They come, they go, and the universe carries on as though they had never bothered to turn up.
But why, though? That's the bit I keep snagging on. Why does the first set stick around and the other 2 just crumble away to nothing? What's so special about the light one?
Now that is a lovely question, and it has a lovely answer, cleaner than the rest of the puzzle. Nothing is special about the light one, except that it is the light one. Picture the 3 generations as a ladder, the lightest copy at the bottom, the heaviest at the top. A heavy particle can always shed its weight and turn into a lighter version of itself. It can fall down a rung, and nature dearly, dearly loves to fall.
So the heavy copies just tumble down the ladder the first chance they get.
The very first instant they're allowed to. Down they go, rung by rung, shedding weight as they drop, until they reach the bottom. And the first generation
Is the bottom rung.
is the bottom rung. There is nothing lighter for it to fall into. It has nowhere left to go. So it simply stays. Not because nature chose it, not because it's the favorite child, but because it is the one rung with no rung beneath it to drop to. You are made of the first generation for the plainest reason in all of physics. It is the only one that cannot fall apart.
Huh, so I'm not built from nature's finest ingredients, I'm built from the only ones that happen to hold still.
The only ones that hold still. Everything grand and lasting about you rests on that one small fact, that the bottom of the ladder has no basement under it. And I love that, honestly, because it's such a modest little reason. It isn't destiny, it isn't design, it's just the floor. But notice what it leaves standing, completely untouched.
It tells me which copy is stable. It doesn't tell me why there are 3 copies to begin with.
It doesn't tell you why there are 3 copies at all. And that is the thing that keeps me awake at night. Why 3? Why not 1 and be done with it? What is the second one for? What is the third? They do no work. They build nothing. They fall apart the moment they're born. And still, they're written into the world.
Right, so why bother making the extra 2 at all if they just fall to bits the instant they appear?
Why bother? Why not 1? Why not 7? Or 107? Why heavier and heavier in those particular steps, and then stopping dead at 3? No 4th, no 5th, just 3 and a full stop. We can write down that it is so. We have checked it every single way there is to check anything. But why nature drafted the same line 3 times over and then only ever speaks the first of them aloud? Nobody knows. Not a soul alive.
And you genuinely don't know. That isn't you tucking the hard part away to keep it simple for me.
That is not me simplifying. That is me showing you the honest edge of what anyone alive knows. Hold on to that loose thread, the two spare copies that nobody can account for. It is far more important than it looks tonight. And it is very much not for this evening.
I'll hold it, though I'll admit there's something almost comic about the arrangement. The entire universe gets built out of one set of ingredients, and the other two are just lying around spare, quietly falling to bits. It's as if nature over-catered a party, cooked the identical dish 3 times over, heavier each round.
And most of the food went off before a single guest arrived. That's honestly not far from the truth of it. 3 servings laid on. The first feeds the entire cosmos. The other 2 get cleared away almost before they've touched the table. And the fact that it looks like waste, that it so plainly needn't have been that way, is exactly the sort of thing that whispers to a physicist, there's a reason down there we simply haven't found yet. A truly finished theory wouldn't cater for a party that nobody ever comes to.
Was there ever a time the universe actually used all 3 of them, though? Or have the heavy copies always just been spares that flare and die?
There was a time, yes, right at the very beginning, when everything was ferociously, unimaginably hot. In those first raw instants, the entire cast got made freely, all 3 generations churning together in the fire, the heavy copies as common as the light ones. But then the universe cooled, and as it cooled, the heavy ones did the only thing they know how to do. They fell down the ladder, decayed away, and never came back. What was left standing, once things had settled, was the first generation, alone. And everything built since has been built from what remained. The spares had their moment. It was very early, and it was very brief.
But even inside one generation, I have to ask, why that shape? 2 quarks and 2 leptons, always paired off like that. Why not 3 quarks and 1 lepton or some other mix? Is that just how it fell out?
It is not an accident, and this is one of the deep and beautiful things. The pieces in each generation are balanced against one another. Their charges, the way they pull on the forces, all of it adds up in just the right way to cancel out. And if you tried to be greedy, keep the quarks, say, but throw away the leptons, the whole theory would spring a leak. It would develop an inconsistency, a mathematical wound that wouldn't heal. The quarks and the leptons come as a matched set because the mathematics simply refuses to hold together otherwise. They need each other to exist.
So it's not, here are some quarks and here are some leptons, and they happen to travel together. It's that neither half is allowed without the other.
Neither half is allowed without the other. Take one piece away, keep the quarks, lose the leptons, and the beautiful structure springs that leak, stops being consistent, stops being a possible world at all. The theory would be describing a universe that simply cannot exist. That is your first real taste of what actually holds this thing up, and we'll come back to it hard in a moment. The matter doesn't sit in a random pile. It sits in matched, balanced sets, because the deep rules of the game will not have it any other way.
All right, so that's the matter. A dozen pieces, in 3 copies matched into sets, and only the first does any of the building. Is that the list then? Is the back of the hand full up?
That's one whole side of it. A dozen matter particles. 6 quarks, 6 leptons, 3 tidy copies of the one pattern. But the matter is only the cast, only the actors, and actors standing about on a bare stage don't actually do anything. They have to be able to reach one another, push and pull, bind and break apart. And that reaching between them, that's the forces. We spent weeks on those, so let me gather them up now in one armful.
Go on then, line them up for me, all of them in a single row. I want to hear exactly how many it comes to.
Here they are. Electricity, magnetism, and light itself. All one single force, all carried by one messenger, the photon. The strong force, the one gluing the quarks together inside every proton and neutron, carried by the gluons. And the weak force, the shy one behind radioactivity, and the slow fires burning in the heart of the sun, carried by a heavy pair, the ones we've been calling the W and the Z. And every one of those forces does its work the same way. One bit of matter throwing a messenger across to another. That is the entire method of it.
The photon, the gluons, the W and the Z, and that's all of the forces? At this level, that's the lot.
That is the lot. Every push and every pull you have ever felt in your life, carried by that short little band of messengers and no others. And notice how different those messengers are, one from the next. The photon weighs nothing at all. That's why light itself flies at the fastest speed there is and reaches you from the far side of the universe. And the weak pair, the W and the Z, are heavy, enormously heavy, which is the whole reason that force is so shy, so short of reach. Last week's field is what made the difference between them. The photon ignored it and stayed weightless. The weak pair leaned into it and came away heavy.
And the gluons, that force never seems to let go.
It never lets go, and that's its whole character. The gluons pull so ferociously hard that they will never, ever let a lone quark escape into the open. Try to drag one out of a proton, and the force only grows the harder you pull, until it's cheaper for nature to snap off a fresh pair than to let the one go free. Which is exactly why you never meet a bare quark wandering about, the way you'll never meet a bare heavy electron. Nature keeps certain doors bolted shut, and that is one of them.
So the quarks are locked away in threes, inside the proton, forever.
Locked away, never out alone, not once in the history of the world. And here is a lovely echo of last week, before we leave the glue behind. Those three quarks penned up inside a proton are feather light, barely a whisper of mass between the lot of them. And yet the proton is heavy. So where does its weight come from? Nearly all of it, and so nearly all of yours, is the raw energy of the glue itself, whipping those quarks around and around, showing up on the scales as heft. The mass field hands weight to the little elementary specks. The strong force provides the rest, and the rest is very nearly all of it.
So most of what I weigh isn't the famous field at all. It's the energy of the glue holding me together.
Most of what you weigh is bottled up motion, yes. The churn of the strong force cashed in as mass, the way Einstein always said it could be. Which brings us, at last, to the one thing left to set down on the table. Last week's guest. The mass field and the ripple we shook loose from it. The particle that hands the little elementary pieces the sliver of weight that is truly theirs.
The one from last week. Set it down beside the others.
Set it down beside the rest and... that is the whole cast. The matter in its three generations, the messengers of the forces, and the mass field's own particle. There is no more. There is no page 2.
Hold on. That's IT? That is the entire shopping list? A dozen bits of matter, a little clutch of messengers, and the one from last week. And out of that comes everything? Every star, every sea, every living thing that's ever drawn breath.
That's IT. Every star, every sea, every living thing that's ever drawn breath, every page of every book ever written, and the eyes moving across them. All of it, top to bottom, runs on that one short roster. And here's the thing that gets me every time. It's the same little list at both ends of the scale. The unthinkably vast and the unthinkably small. A galaxy of 100 billion suns and the single point of a pin. The oldest light in the sky and the warmth of the person sitting next to you. All of it, the biggest and the smallest, and everything strung between them, spelt out of those same few ingredients. You really could write the entire thing on the back of your hand and still have room left over for the date.
Let me actually try it then. Quarks, up, down, and the two heavy pairs above them, that's a thumb. Leptons, electron, its ghost, and the two heavy cousins, each with a ghost of its own. That's a finger, maybe two. photon, gluons, the W and the Z, the mass particle. That isn't even a full hand.
That isn't even a full hand. And that is the exact moment I wanted you to feel tonight. Not the cleverness of it, not the machinery underneath, just the astonishing, almost embarrassing shortness of the thing. Everything you have ever known, or seen, or been, out of that little scrawl on your palm.
It's genuinely a lot to take in. I walked in braced for your warehouse, and you've handed me a menu I could read out loud in a single breath.
In a single breath, and slowly at that. And here's a small secret about that shortness. It is not a convenience we imposed to make the thing easy to teach. It's a fact about the world that we stumbled into and did not expect, and could scarcely make ourselves believe when it finally arrived. Because every step down before it had gone the other way. Crack open the atom, and you found a nucleus and a swarm of electrons. More pieces. Crack open the nucleus, and out came protons and neutrons. More pieces still. Everyone braced for the same thing again. Split those and drown in 1,000 more. And instead, one layer deeper, the flood dried up. It got simpler. The universe simply turns out to be spelt with very few letters. The wonder was never that there is so much down at the bottom. It's that there is so little, doing so very much.
But, let me push on you here, a list is only ever a list. If I write those names across my hand, quarks, leptons, photon, gluons, the weak pair, the mass particle, that's an inventory. It isn't a theory. It doesn't tell me how any of it hangs together, or why it should. So what is it that turns the list into a picture?
Ah, and there's the hinge of the whole thing. This is precisely where it stops being a stamp collection and becomes something deep. Two ideas hold all of it up. Just two, and they are the very two we've spent this entire season, and the season before it, quietly walking towards. Take the first. Every single item on that list, every quark, every electron, the photon, all of them, is not really a little ball sitting somewhere in space. It's a ripple.
A ripple, in a field. You're cashing in the great reveal from the quantum season.
The very thing. Fill all of space, every empty inch of it, out past the last star there is, with an invisible something, a field. One field for each kind of particle. And a particle is nothing but a ripple raised up in its own field. An electron is a ripple in the electron field. A photon, a ripple in the light field. So that list you scribbled on the back of your hand is really a list of oceans filling the universe from edge to edge, and the particles are only the places where those oceans happen to be rippling.
One ocean for each kind of thing, and everything else is weather riding on top of it. I remember that from the quantum finale.
You've got it exactly, and it has consequences that go deep. It means even the emptiest patch of space, a box with every last particle pumped clean out of it, still has all those oceans lying in it, flat and still and waiting. There is no such thing as truly empty, there's only the fields, at rest. It means making a brand new particle isn't conjuring a thing from nothing. It's just raising a fresh ripple where the ocean was flat. And it means two electrons anywhere in the universe are perfectly, exactly identical, with no scratch and no serial number to tell them apart. Because they aren't two little things that happen to match. They're the same one ocean, heaved up in two different places.
So the first pillar is everything, all of it, is a ripple in a field. And the second?
The second is the one I find harder to believe even now, after all these years, and it's the deeper of the two. It's symmetry. Cast your mind back a couple of weeks to where the forces actually came from. We did not put them in by hand. We found that if you insist the world obey a certain deep symmetry, that it carry on looking precisely the same, even under a change you're allowed to make differently at every separate point in space, then the forces are not optional extras you bolt on afterwards. They are forced into being by that one demand.
Give me a feel for it. A change you can make differently at every point. I need something to hold there.
Then try this. Imagine there's some dial you could turn, everywhere, and the laws of the world simply don't care what you set it to. Turn it up, turn it down, the physics comes out identical. That's a symmetry, a change that leaves the world looking exactly as it did. Now here's the demanding part. Insist that you're allowed to set that dial to one thing here and something quite different over there. A separate setting at every single point in space, however wildly they disagree. For the laws to survive that, to stay untouched, no matter how much the dial jumps from place to place, something has to reach between the points and reconcile them, patch up the mismatch, carry word from here to there. And that something is a force. The messenger is the patch. It is the very thing the world has to grow in order to keep the symmetry honest across every point in space. Which is why I say the force isn't chosen, it's demanded.
So the force isn't a thing added on top of the matter, it's the price the world pays to keep that symmetry intact.
The price the world pays, no more, no less. And that is the astonishing marriage sitting right underneath the entire picture. The particles are ripples in fields. The forces between them are dictated right down to their character by symmetry. And remember those matched sets from before, the quarks and leptons that refuse to exist without each other. That's the same symmetry insisting the books balance. Two ideas, quantum fields and symmetry, and between just those two, they carry the entire weight of everything on the list. Every player and every rule of the game the players play, falling straight out of two deep thoughts.
That's not an inventory anymore, is it?
That is not an inventory anymore. That is a theory of the world. And the thing has a name, a modest one. Comically modest, honestly, for what it is. We call it the Standard Model.
The Standard Model. That's the grand title for the deepest thing we know.
The plainest, dullest name you could possibly dream up, hung on the deepest map of matter our species has ever drawn. It's as though somebody found the crown jewels and labelled the box assorted items.
Assorted items. The most successful theory in the history of the world filed under standard. You people really are the worst at naming things.
The very worst. You should hear some of the words we hung on the quarks. But that dull little name hides the one thing I most want you to grasp tonight. Because Standard Model sounds like a parts catalogue you'd flick straight past. And what it actually is the single most rigorously tested idea the human mind has ever produced. Which drops us right back onto your other question, the hard one from the very top of the hour.
How can we possibly be so sure the thing is true?
How can we possibly be so sure? And I have been saving the answer up for right here, this exact spot.
Then give it to me. No comfort, no rounding off. Because a short, pretty list is one thing. Being certain it is actually true is a completely different thing. So how sure are we, really, honestly?
Then let me tell you, and let it land. Because this is the part that earns every last scrap of the ore. This theory does not merely tidy up what we already knew. That's the easy trick. Any clever story can be dressed up to fit the facts you already hold in your hand. No, this one sticks its neck right out over the edge, where it can be chopped clean off. It looks at the pattern it is built on, and it says, there must be a particle here that no one has ever seen, with roughly this weight and this behavior. So go and look, over there, in that exact spot. That's a dangerous thing for a theory to do. It's the theory betting its own life. And then somebody goes and looks in precisely the place it pointed at. And there it is. Every time. The bet keeps paying out.
It predicted particles, whole particles, before anyone had ever laid eyes on them.
Before a single soul had seen so much as a trace. Take that heavy pair carrying the weak force, the W and the Z. They were written into the theory before anyone had found either one, described in advance, the weight of them, the manner of them, the character of them. And then the hunt went out into the world, and there they were, just as promised, waiting where the equations said they'd be.
That's one. You said it did this more than the once.
More than once, and each time bolder. The heaviest quark, the great one crowning the third generation. The theory swore blind the pattern needed it, and even said roughly how heavy the thing would have to be. People went looking. It turned up, right where it was meant to. And then last week's guest, the mass particle. Predicted, argued over, chased across an entire generation of searching. And in the end, there it was. Precisely the ripple the theory had promised, sitting exactly where it said to dig.
So these aren't stories we cook up afterwards to make ourselves feel clever. It genuinely called its shots, out loud, in advance.
It called its shots out loud, in advance, and then it made them, one after another after another. And that is still only half of why we trust it, because it doesn't only tell you what exists, it tells you how each thing will behave, how strongly, how often, which way a particle will jump when you nudge it, and those numbers come out right as well. Not just the roster, the whole run of play.
And how right is right? Give me the size of it. Make me actually feel how fine.
Picture measuring the distance clean across a whole continent, coast to coast, thousands upon thousands of miles of solid ground, mountains and rivers and all, and getting your answer right to within the thickness of a single human hair. Not close, not roughly, right to the hair. That fine. The theory hands you a number, worked out from nothing but the ideas on your palm. Then you go out into the world and you measure that same number for yourself by a completely different road, as carefully as human beings know how to measure anything at all. And the two of them, the number from the pure thought and the number from the stubborn world, lie down together, right out to that many places past the decimal, digit after matching digit.
And that's not a one-off, not just a lucky lineup on one number that somebody got excited about.
Not a fluke, and not just the one. Again and again, everywhere we have ever been sharp enough to test it that hard, the theory's number and the world's number agree to a fineness like that. Coast to coast, and quarrelling over a hair.
I don't think my head has the room for how precise that actually is. You're stretched right across an entire continent, and you're arguing about the width of one single hair.
Arguing about a hair, and the theory keeps winning the argument. And here is the line that still lifts the hairs on my own arm after all this time. In all of that testing, every shot called, every number checked to that ludicrous fineness, over decades of clever, ambitious, hungry people trying their absolute hardest to catch the thing out in a lie, it has never once been caught. Not once. Every single time we've built an instrument sharp enough to trip it up, it has stood there and passed.
So the entire scientific world has spent lifetimes doing its level best to prove the wretched thing wrong, as hard as they possibly can, because that is how you make your name in this business, and it just keeps on being right.
Keeps on being right. Maddeningly, gloriously right to every last person who ever dreamed of being the one to finally break it. That is what I meant right at the top of the hour when I told you this ridiculous shortlist has never been caught out. It is not a turn of phrase. It's the plain, tested, decades-long fact of the matter. The shortest recipe you ever saw is also the most precisely confirmed thing our whole species has ever managed to write down.
Never. Not once. Not even a hair off, somewhere, on some stubborn old measurement that just wouldn't sit down.
Within everything it was built to describe. No, not once, and not by a hair. Every disagreement anyone ever thought they'd caught has, in the end, come out the theory's way. or come out to be a slip in the measuring, not a flaw in the map. It is the nearest thing to an unbeaten record that science has ever kept. Lifetimes of the sharpest people alive, swinging at it with the finest instruments ever built, and not one clean hit has ever landed.
And this move, predict a thing on paper, then go out and actually find it in the world, physics has pulled that before, hasn't it? You've hinted at it more than once across the season.
It has, and it is an old and honourable move. Cast your mind back seasons to Dirac, a man who trusted his own mathematics enough to declare there simply must be a mirror twin of the electron out there, purely because his equation insisted on one long before anybody had glimpsed so much as a whisper of antimatter. He could so easily have crossed the thing out, called it a smudge, an embarrassment, a bit of the maths that didn't mean anything. Instead, he believed the equation over his own common sense, and then, out it came, into the world, exactly as written on his page. The standard model is that same faith in the mathematics, grown all the way up and proven right over and over and over on a scale Dirac never lived to see.
When the equations run deep enough, they seem to know things about the world before we do.
Before we do. Dirac caught the first clear glimpse of that unsettling fact, and this whole theory has lived on it ever since. And you might well ask, how does anyone even calculate one of these numbers? To land across a continent precise, that is plainly not arithmetic on the back of an envelope.
I was about to ask you exactly that. How do you even work one out?
That was Feynman, more than anyone. A way of drawing the entire business as little pictures. Ripples meeting ripples, this field giving that one a nudge, and then reading a number straight off the drawing. Because down there, when two particles so much as brush past each other, there isn't one thing that happens. There's a whole storm of ways it could go, and nature quietly adds every one of them up. Feynman found a way to draw each of those ways as a simple sketch, tot them up, and get an answer, turning a bottomless tangle into something a person could actually sit down and calculate. Every one of those absurdly precise predictions I've been boasting about gets worked out in that language. The deep ideas make the theory beautiful. Feynman's little pictures are how you make it actually pay out, right down to the last decimal.
All right, I believe you it's short, and I believe you it's true. But I want to lean on that word you keep reaching for, everything. When you say this back-of-the-hand list explains everything I've ever seen, you're being a touch loose, surely. What does it honestly reach? Where does it actually bite down?
Then let me not be loose. Let me spend it, because the sweep of it is the reward for the whole climb. Begin with chemistry. The entire periodic table, every element there is, and why each one behaves the way it does, why one is a metal and the next a gas that won't react with anything, comes down to how the electrons arrange themselves around the nucleus. And every reaction there has ever been, everything that has burned or dissolved or rusted or come alive and grown, is those electrons shuffling about under the electric force, changing partners. That's on the list. The whole of chemistry, every reaction in every living cell of you right now, falls out of a few short lines of it.
The whole of chemistry out of the list? Keep going. Don't spare me a single thing.
The makeup of every atom there is, why it holds together at all, why it has the size and shape it has, the quarks lashed tight by the gluons into the nucleus, the electrons held out in their shells by the electric force. On the list, why solid things are solid, why you don't simply sink straight through your own chair. That's those same electrons refusing to be crowded into the same spot, holding matter apart and giving it its stubborn bulk. On the list.
Even the solidity of the ground under my feet.
Even that. And keep going, because it doesn't stop. Every spark of electricity in every wire, every magnet on every door, every color you have ever admired, all of it is that one electric force and light and electrons going about their business. The warmth of sunlight landing on your face A short while after it left the sun, the rainbow that same light gets bent into by the rain. Every green and growing thing quietly drinking that light down and building itself out of it. And then up to the very biggest things there are. Why the sun shines at all, and every star scattered across the entire night sky. That is the weak force and the strong force laboring deep in their cores, fusing light matter into heavier and turning a sliver of mass into a flood of light.
And that last part, mass turning into light, that's Einstein's old bargain.
Einstein's old bargain, cached in the belly of every star that burns. Mass paid straight out as energy. On the list. And even the slow tick of radioactivity, an unstable atom sitting there, patient, and then, on no schedule anyone can ever read, quietly letting go. That is the shy, weak force again, doing its quiet work in the dark. On the list. All of it.
So it really genuinely isn't a figure of speech, this everything you keep saying.
It really isn't. The ground of all chemistry, the makeup of every atom, the bulk of every solid thing, the spark in every wire, the color of everything you've ever loved the look of, the fire in the heart of every star, the slow clock ticking inside the rock, the light that has crossed half the universe to land this very night in your eye. Very nearly everything you have ever laid your eyes on in all of your life, resting on that one short list you could ink across the back of a hand. That is the reach of it, not a metaphor, a true accounting of nearly the entire visible world, and it fits inside your open palm.
I want to just stop for a second and sit in that, because I don't think I properly clocked, until right this minute, how far the two of us have actually come this season.
Then let's stop and sit in it, because you truly ought to feel the distance we've walked together. Cast your mind all the way back, right the way back to the first night this season began.
The zoo.
The zoo. We opened weeks ago, the pair of us standing in front of an absolute shambles. A mob of particles, well past 100 of them, pouring in faster than anyone could think up names for them. Every last one being called elementary, and not one shred of order to the roaring crowd of them. It looked like a catastrophe. It looked, honestly, as though physics had lost the plot entirely.
I remember it well. It felt genuinely hopeless that first night. 100 and more so-called fundamental things, and no sense to be made of a single one of them.
And now look where the two of us are standing. That entire roaring zoo, every one of those 100 and more particles, turned out to be built from the tiny handful sitting on the back of your hand. A few quarks and leptons, arranged and rearranged, bound together and lit up by a few forces. The mob was never the truth of the world. The mob was only the surface of it. And underneath, the entire time, quietly waiting to be found, was this. A short, calm, near-perfect order.
From that chaos to this.
From that chaos to this. And that journey, from a bewildering, hopeless mess to a small handful of ingredients in almost flawless arrangement, is, I think, in all honesty, one of the great achievements of the human mind. And it cost what those things always cost. Lifetimes of work, a great many wrong turnings, thousands upon thousands of people, most of whose names you will never hear, each adding one small, honest brick to the wall and handing the trowel on. Not any one person's triumph. Ours. The whole patient, stubborn species that stared straight into the zoo and flatly refused to believe it was the bottom.
And the first crack of that order, the very first hint the zoo had families hiding inside it. That was the pattern, wasn't it?
That was Gell-Mann and others feeling their way through the dark alongside him, spotting that the shambles fell into shapes, into rows and columns, the way the elements themselves once had, long before anyone knew an atom even had an inside. And you know what that echo told him, because we'd all seen it before. The last time a hopeless list of things fell into neat rows, The rose turned out to be a fingerprint, a sign the things weren't fundamental at all, but built from a few smaller pieces underneath. So the pattern in the zoo was a promise. It said, "Look deeper, there's an order here, there are fewer things than you fear." That pattern was the first thin line of light under the door. And tonight is the room, with the light switched full on. Same journey exactly. It only took us a season to walk from the one to the other.
So then, and I almost don't want to ask this because it is all going so beautifully, but I have to. Is that it? Have we actually done it? Is this the finish line? The whole of everything, wrapped up neat, sitting on the back of a hand. Are we done?
Nervously.
You've gone quiet on me.
I have. Because it is the fairest question you could put to me tonight, and I don't want to answer it too fast, or too cheap. You have every right to ask it. A theory this short, this beautiful, this ruthlessly, relentlessly tested. Of course, you look at the thing and think, surely that has to be the bottom of it. Surely that is the whole truth.
But the pause is telling me it isn't.
The pause is telling you it isn't. No, we are not done. For all of it, all that precision, all that triumph, there are things this magnificent picture cannot touch at all. Great, enormous things, sitting right out in the plain open, that it has simply nothing whatsoever to say about. But that is next week's story. I won't spoil it tonight. Tonight belongs to the triumph, and the triumph has earned itself one undivided evening.
You're really going to leave it there. One flat no and a locked door.
One flat no and a locked door, and I'm doing it on purpose, because tonight deserves to be exactly what it is, with no shadow thrown across it. There'll be time enough for shadows, there's a whole evening of them coming. But if I let even a corner of that in now, you'd carry it home instead of this, and this is the thing worth carrying. The most successful theory ever written by human hands, the entire visible universe set down on the back of a single hand, tested past any reasonable doubt, and never once, in all of it, caught in a lie. Let that stand on its own for one night. It has more than earned the right to.
All right, I'll let it stand. But give me the shape of next week at least. Just the shape of it, mind, not the substance.
Just the shape, then. Next week we do the bravest thing a good theory ever lets you do. We stop admiring it, and we turn it right over in our hands, and we look, honestly, without once flinching, at everything it cannot explain. And that's a thing you can only do with a theory you trust completely. A shaky one you'd rush to defend. You'd paper over its gaps and hope nobody looked too closely. But a theory this solid, this tested, you can afford to be merciless with it. You can go hunting its own limits out loud, in front of everyone, because you know it can take the weight. So we'll start with the most familiar force in your entire life. The one holding you down in that chair this very second. The one you have felt every single waking moment since the day you were born.
Oh, don't. Don't you dare tell me.
It isn't in the picture at all. Not anywhere on that back of the hand list. The most magnificent theory we have ever built, and the plainest, oldest force you know, is simply, quietly, missing from it.
Of course it is. You hand me the entire universe on my open palm, and then, right at the death, you lean across and tell me the very thing pulling me down into my own seat isn't even written on the page.
That's the job. To give you the triumph honestly, and then, just as honestly, the crack running right through it. If I gave you only the triumph, I'd be a salesman. If I gave you only the crack, I'd be a cynic, and I'd have robbed you of the most beautiful thing our species ever worked out. So you get both, but each in its own good time. And tonight is the triumph's night. Look only at what we have actually got. Everything you are, everything you have ever seen, set down in a dozen pieces and a few forces and one last field, on the back of a single hand. And true, as far as we have ever been able to test that word true. Sit with the whole picture for one night. The cracks can keep until the morning.
The whole picture, on the back of a hand. I'll sit with it. Next time then, the cracks in the picture, and the one plain force that isn't even on the page. But not tonight. Tonight I think I'll just turn my hand over and look at it a while and let myself think. All of it. The whole visible universe, every star and every stone, and the person listening, and me. A dozen pieces, a few forces, one last field, and out of that, everything there is, right there, on the back of a hand.